So we're still doing sum and difference identities. So it's the same formulas. Same formulas. Different context, maybe is a word to say. Different context. Today we're not on the unit circle. For a few of you, that's great news. For most of you, you're fine on the unit circle by now. But if you're still struggling with unit circle, you don't need it today. Sometimes we want to find the exact value of a trig function, but we are given information in a different form. Consider the following situations. We're given that sine of A equals 3/5 with angle A in quadrant 1. Well, let's draw that and see what it looks like. Your triangle doesn't really need to be to scale, but it does need to be in the right quadrant. If you put it in the wrong quadrant, you will probably miss the problem. All right, how am I going to label the sides? Like, what is sine? That's a very open-ended question. That's why nobody knows how to answer that. What are the letters that go with sine? There we go. O over H, opposite over hypotenuse. Or Y over R. But most people still remember SOHCAHTOA. So opposite is 3, because the angle is always at the origin. So the opposite is always the Y side. Hypotenuse is always the R, that's 5. Oh, and they gave us a nice one here, because the missing side, it's a 3, 4, 5. If for some reason you didn't remember 3, 4, 5, or more likely if they give you one that's not a nice one, how would you find that missing side? A squared plus B squared equals C squared. All right, so that's sort of part 1 of the given information. Part 2 of the given information, cosine of B equals 5/13, angle B in quadrant 4. Quadrant 4. Cosine is SOHCAHTOA, adjacent over hypotenuse. So the adjacent is 5, the hypotenuse is 13. What's my missing side? Yeah, careful. 12, but negative 12 because it's going down. So today's another day where it's helpful to know 3, 4, 5, 5, 12, 13. Oh, good question about the 13, whether it's positive or negative. The hypotenuse is always positive.
Okay, I remember that.
Yeah, so you're right. It's like, well, it's kind of going down. What do we do with that? Hypotenuse is always positive.
Okay.
It's only the x and y that might be negative. One thing I did not do that I definitely need to do is label these angles. This was angle A, and this was angle B. And I don't really need to put it in there. I just need to make sure, because I'm going to be referring back to those. So if I don't label them, sometimes I get confused on who's who. So picture A, picture B. All right, all of that is the setup, which, while I'm thinking about it, makes grading this test a pain, because if you miss something here in the setup, like the quadrant or the side length or the sign, then obviously you're going to miss the question. And so then it's on me to be like, okay, well, why did they miss this question? And go back and find the mistake. And if you make a mistake here, you're going to miss both of these questions. So please double check as you do your picture to make sure everything is right, because you're going to have 2 or 3 questions that depend on the picture. So speaking of that, opposite over hypotenuse, opposite hypotenuse, adjacent hypotenuse, adjacent hypotenuse. 4 is positive, 12 is negative. So just making sure.
For the most part, is it going to be those like sets of numbers?
Usually, because it just makes the test go a little quicker for you. Mm-hmm. You're not stuck trying to do a squared plus b squared equals c squared.
Yeah.
Which you know how to do. It's just time consuming. I don't know yet if it's calculator or no calculator. Because all of this could be no calculator quite easily. Let's see, sine of a plus b. Well, we know what that, well, I mean, not remember what it is, but we can look up what it is. We'll be given what it is. Sine of A, cosine of B, plus cosine of A, sine of B. We're given that. I've just worked the examples so many times that I've got it memorized just by doing it so many times. All right, the sine of A. So I go to angle A. Again, make sure you go to angle A, don't go to B. Angle A, sine is opposite over hypotenuse, so 3/5. The sine of A is 3/5. It's not the sine of 3/5. Pet peeve. The sine of A is 3/5. So don't write sine of 3/5. Just write 3/5. All right, the cosine of B. I can start picking on people now because we've got pictures and now it's just sines and cosines. So, Jamil, what's the cosine of B? Cosine is adjacent over hypotenuse. So look at angle B and tell me adjacent over hypotenuse. 5/13. And you know, you can kind of go overboard on labeling stuff, but if it helps, nothing wrong with that. Cosine of A. Haven, what's the cosine of A? 4/5. And Crystal, what's the sine of B? Yeah, -12/13, opposite over hypotenuse. Okay, multiplying fractions. We just multiply across. 3 times 5 is 15. 5 times 13 is 65. This is why you would want a calculator, so I need to check and see if you get a calculator or not. I think you will, because there's more ugly fraction stuff. Plus -48/65. That's kind of convenient that you get a common denominator. So -33/65. So
we have to write sine of A plus B equals.
no, you wouldn't have to write. The question was, do I need to write that? You don't have to. So same formula from Friday, same set of formulas, but instead of landing on the unit circle, we're using pictures. Cosine of A minus B. So we go to the formula chart, cosine A, cosine B, plus sine of A, sine of B. I'm going to press pause and let you try that one. Again, write out the formula, plug in the pieces, take care of the math. It's just a matter of being careful. Number 6, we're given that, so it's a little bit different information. Given that tangent of u equals -5/12, where u is between pi/2 and pi. So now we're going to have to do u and v. Pardon? Yeah. So it's the same type thing. What quadrant am I drawing that in if u is between pi/2 and pi? 0, pi/2, pi, 3 pi/2. So yes, let's draw that in quadrant 2. Tangent is opposite over adjacent. So 5 and 12, where did the negative come from? Yeah, the 12 is backwards, so the 12 is negative. So that one didn't really explicitly tell you where the negative came from, but the 12 is backwards and the 5 isn't. and 5, 12, 13. Always positive. So we're good there. So there's our first picture. Second picture. Why don't you see if you can draw the second picture? There's the start of my picture for V. Hope I should label that. What's the missing side in V? In angle V? 3? You're going to miss this problem if you say it's 3. Negative 3. So always be paying attention to the negatives. So negative 3 because it's down. Alright, tangent of U plus V. So that's tangent of U plus tangent of V over 1 minus tangent of U, tangent of V. Again, you don't have to have these memorized, but chances are, after you've used them a bunch of times, they might stick, accidentally stick. What a shame to accidentally learn something. Alright, tangent of U, opposite over adjacent. So negative 5/12. Tangent of V. What's the tangent of V going to be? 3/4. Let's do the getting rid of the negatives on the fly here. Make it a little bit simpler. Opposite over adjacent. Negative 3 over negative 4 is 3/4. 1 minus. Okay, careful with the signs. 1 minus is part of the formula. Tangent of U is negative 5/12. Tangent of V is 3/4. Okay, now we get to work on our algebra skills here. I don't really want to get a common denominator. I'd rather just multiply through by something to make them go away. So what could I multiply through by that would make all my denominators go away? Why don't we just multiply by all the denominators? So I'm going to multiply everybody by 12 and by 4. Okay, this is algebra, but this is where we hit speed bumps here. So 5/12 times 12 times 4. What cancels? The 12. So I'm left with negative 5 times 4. No more fraction though. 3/4 times 12 times 4. The 4's canceled. So I'm left with 3 times 12, which is 36. So I'm just showing a few more steps here. In the bottom, the first term, there's nothing there to cancel, so I've still got 12 times 4. In the second term on the bottom, the 12 and the 4 will cancel. So I'm going to end up with, you know what, I'm just going to make this positive because the two negatives. I'm going to end up with just 5 times 3. So negative 20 plus 36 over 48 plus 15. So that would be 16 over 63. Olivia?
Does it make them really negative since you canceled the 5?
Where are we looking at?
Because you combine the negatives to make that a positive 5.
Yes.
So that's 3 positive 2.
Yes, because these are all being multiplied together. Negative times positive would make a positive. Yeah. Why don't you try B? Write the formula. Again, and some people will skip steps here, but I think it's wise to write the formula first rather than trying to plug into the formula while you're writing the formula. So I'm going to pause and let you see if you can finish part B. Again, be careful with all of the negatives in there. I think most of the mistakes in this unit, or on this lesson anyway, happen with negative stuff. It's like, we'll give you the formulas. You're pretty good at drawing the pictures. You know your quadrants. You know SOHCAHTOA. You know the right triangles. It's just a matter of like record keeping, being careful as you fill in the blanks. All right, last example, because there's one page of notes today. Number 7, we're given that secant of m equals 5/3, with m being between 3 pi over 2 and 2 pi. So what quadrant are we in there? 4. If you catch that early enough, you can draw your picture such that your picture is mostly just the quadrant that you need. Wasting space. Let's see, secant. I don't like secant. Who is secant? Partners with cosine. Cosine's ka, so secant is ha, I guess. So the hypotenuse is 5, the adjacent is 3. What's the missing side?
4.
Is it 4?
Negative 4.
Negative 4. And then for n, not in quadrant 4. Okay, well I guess that's helpful. Cotangent is negative. That's adjacent over opposite, but I need to know what quadrant to put it in. Who has a negative cotangent? Negative cotangent. Use that differently. Cotangent is negative in quadrant. All students take calculus. So tangent is positive in first and third. So this is the trickiest thing we can do with these. So cotangent is negative, but it's not in quadrant 4. Therefore, it has to be in quadrant 2. Because that's the only other place that has a negative cotangent. Adjacent is 12. Opposite is 5. Where did that negative sign come from? The 12. And then the missing side is 13. And I should probably label that so I don't get confused later. That's triangle in, or angle in. Let's do just the tangent one because I'm worried about the algebra. Tangent of m minus tangent of n over 1 plus tangent of m, tangent of n. M's and n's. So very carefully, tangent of m, opposite over adjacent, tangent of n, opposite over adjacent, 1 plus those two, negative 4/3, negative 5/12. So what should I multiply by to clear out all the denominators? 3 and 12. So 3's cancel. I get negative 4. Negative negative becomes plus. 12's cancel. 15. Wait, what did I do wrong? Oh, I canceled the 3 but didn't multiply by the 12. Over 36 plus the 3 and the 12 both cancel, so 36 plus 5. Again, I'm really just worried about the algebra on these problems. So negative 33 over 56. Wait a minute. What did I do wrong? Oh, the key is wrong that I'm looking at. Yeah, I'm good. So your assignment today is worksheet 2 in the packet. Again, it's a lot of drawing pictures. Please be sure to take the time to get your picture right, because the picture's wrong, blows up after that. Ty? Yeah. Haven, same thing.